Okay, so in the afternoon, we are going to look at the COVID-19 case data as a practical example to learn R. So, and this is if you click on the website, the GitHub website, it's linked to the code we are going to use, learning R through JHU COVID-19 data analysis. It's the RMD file. So this is also in Unit 1. It's a different R Markdown file than from the GSAT web. I also just updated, correct a few typos again. And if you want to also sync with the GitHub, that's going to correct a few typos there as well. For those who are not familiar with the Johns Hopkins COVID-19 data, this is one of the first few real-time, well, near real-time COVID-19 transmission data site put up. In early days, I remember in early 2020, there are very few data to report COVID-19 cases by counties. And the Johns Hopkins website actually is one of the first to provide a real-time case by counties. And this is by far is still one of the most popular data sites. It's actually not an official site. It's not a CDC or WHO or sponsored by any state. So this, they may have federal funding though by now. So, but it's a public GitHub repository. In fact, you can see it has been forked 17,000 times. So, including myself, I guess. So, I contributed one fork there. So, in their release side, you do see they are not the data generating, they are just collecting the data. But what they do is they collecting the data from various sites, but then they merge them in a CSV format. So that's the WHO COVID situation report. That's the CSSE. CSSE is something called Center for System Science and Engineering. I guess that's what their name is. CSSE. JHU for Johns Hopkins University. So once you click that CSSE COVID-19 data folder, then we see there are time series, daily report, and daily report US. And we are going to just look at the time series data directly. So it also has the recovered, death, and confirmed data. Oh no, those are deprecated, sorry. Let me see. Oh, it does still have it. So it has the death US, confirmed US, but there's no recovered US anymore, I guess. Yeah. So this is actually, if you think about how the data are collected and then merged, there are a lot of errors. In fact, there are errors all the time. And we will see those errors when we start to analyze this kind of data. But this is clearly a real, a practical data set is there. So, okay. So, anyone has trouble to open up the R Markdown file? If you do, please raise your hand on Zoom and then join a breakout room so the TA can help you with it. It looks like someone's still in the breakout room. That means you cannot even listen to me right now. So that's kind of a weird. Yeah, so I'm going to, someone raised their hand. Can you go to room number 3? To go ahead with the COVID-19 data analysis probably. I still hear a little echoing. Someone still unmuted. I don't know who. Please mute yourself. So, okay. There's actually a Wikipedia entry for the Johns Hopkins COVID-19 data site. So, and we are going to use tidyverse, ggplot, Ruberdate. So if you run the first block, if you see an error, and then you need to install the package. So, yep. Monique, please join break room number 3. And is the TA here?
Yeah, I think the. Oh, okay, yeah, I'll go in there.
Monique, can you join room number? Oh, Monique is already there. So
I think room 3 has someone who left and her mic's unmuted, so you're playing through.
oh, I see.
So I'll probably send him to room 4.
Okay. Anyone have trouble with the package? If not, I will move to the next one. So, well, the good thing about the Johns Hopkins COVID-19 data, we can directly read it from the website. So the next code just read the Johns Hopkins COVID data from its website. There. So once you run that chunk, you will see on the top right environment, you now see a data called TB. That is a data frame. It says 3342 observations, 492 variables. If you click on that, in RStudio, it actually pop up just like a spreadsheet. So, and those are the rows. So rows, these are actually 3,300, 442 rows. And those are basically counties in the United States. So this is a county level COVID-19 transmission data. It's very, so it can be used for local reporting or prediction. So so UIDs, OS, I have no idea what those mean, but apparently admin 2 is a county name, province and state, that's the corresponding to each state of the United States. And the country or region, they are all US in this case. So, and if we scroll to the right, and you also see latitude, longitude, you can't see longitude, there's underscore there. That's probably a typo in the beginning, but it really doesn't matter. And so this typo never corrected, and apparently it's still there. So there's also the combined key. That's basically the county name, state, and country name. This is useful later on when you combine, if you want to combine this with a different country, different state. Apparently, there are many county names are the same in different states. For example, Hamilton County, Tennessee, there's actually a couple of other states also have Hamilton County. So, yeah. And then you will see January 22nd, 2020. Apparently, that's the first reported that may not be the first case in the US, but that's the first reported data there. So from January 22nd, 23rd, 24th, and then you will scroll all the way to the right. In fact, you can go all the way to the, with the May 16, 2021. Today is what? Today is May 17. So all the way to yesterday. So this is not real time, but near real time. So today, I guess tomorrow you will see May 17 if you want to really follow up with this. So basically, each date is a column, each county is a row. This is typical Excel spreadsheet operation. So, I mean, there are cases that you may want to do daily analysis on all county, but in our case, we are going to analyze the time series of each county. So the first thing we are going to do is actually, again, change all the rows into column, change all the column into rows. So that's called transpose. Some of you may have taken linear algebra. That's basically a transpose operation on the matrix. So, I'm talking about matrix of linear algebra, not the movie matrix. So, okay, so we first read into that as a data frame. And this is just a review of the data frame. You can use the square bracket to index it. And someone joined the sorry, I clicked when someone asked for help join Breakout Room, I clicked the wrong button. So, okay, back. Someone please join the Breakout Room to help a student there. So, okay, I'm still sharing the right screen. So, so square bracket for indexing, and we can use C, and apparently that's C for combine to specify rows and columns for indexing. So, and we can also specify the column name. In this case, admin2 FIPS province state. FIPS apparently is one of the ways in the United States to specify a location. I don't know what it is, but anyway, that's the code number. So, apparently, Chambers, Alabama had a code, something called 1017. Yeah, almost like a zip code, I guess. Yeah, but it is not a zip code. It's something called FIPS. So, okay, so we can use the header again to look at the first few rows. We can also specify which column and how many rows we want to look at it in the header information. So, and we can also use the length to find out how many columns. That's basically the list in that first row. In this case, there are 492 columns. But which row does it start with? The case is actually row, which column is actually column 12 to the last one. Those are actually the cases. So we are going to select all the columns of daily cases and then do a transpose. Rotate the data frame so that each county now is in one column. So, and the way we are going to do it, this actually using tidyverse is much more easy than the basic R. So we are going to take that data frame, select from the 12th column to the last column, change that into a matrix, and then we just do a transpose of that matrix and put it back as data frame. And then look at this data frame again. So, okay, this is now we call it column TB1. So if you now we go back to the environment, now you see the TB1. Now we have what 481 observations and what 342 variables. So on the first day, all the way to the May 16, and then each column is now accounted. Now, well, you see, now we don't have the county name anymore, so we need to add a meaningful column name as the put the county name back. This is what the next chunk of code trying to do. We need to add a meaningful column name to our new data table or data frame. So this can be done by using the command column names. So we're going to rename the column of TB1. And what we are going to use is just use the combined key from the original data table. So let's run that. So once we run that, now if we look at the table one, TB1 again, now we see there, Augusta, Alabama, US, that's the first column. Baldwin, Alabama, this probably just alphabetical order. So. But this is exactly the same order as the original table. So. And now notice that the date also use the United States format. The United States date convention is month, date, and year. So that's actually not a very scientific way to do this because that means you have to order, if you do a sorting by that text, you're going to order by month. And then the date 0110, it may or may not be in the right format. So, and we are going to now we're going to use a looper date. Looper date going to have many useful function to convert the string format into the actual date. So for the United States, because we use a month, date, and year, so NDY is short for, and then we can convert that into the standard year. So now we have the 2020. If you do that, it's going to change that into year 2020, and 10 is October, 1 is the first day. So now we change that to year, month, and the date, which I guess is more logical, and also because that's how the way that if you really align them, that's actually how we're going to align the date in an orderly way. So, so the original date is here. Those are actually all in characters. So we're going to change all those. Those are the original data as a column name, and we call that current date. And class, that's just to check the data type of that current date. It's actually character. So that's the original date. I probably should shorten that. And then we are going to use MDY to change that into the standard date, which is 2020, year, month, and the date. And then we're going to assign that. Someone in breakout number 2 need to look for help. Okay. It looks like the TA is not available. Unfortunately, not enough TA are available right now. It looks like the TA, some of the TA has not come back from lunch yet. Okay, there's one TA in breakout number 2 now. Okay. So in this case, we are going to convert all the original date into the standard one, then assign as a new variable in our data frame called date. And once we do that, if we go all the way to the back, actually it will be much easier if we open up the spreadsheet to look at the last one. Yes, there. At the very end, now we have a new column date, and that's the standard date. Anyone need help with this? Okay. So, and then once we actually have the date of the type that the computer can recognize, we can actually now analyze the date as the time. We can pick a time window. So in this case, we are going to select a time window using the filter command. We're going to pick dates, which is the after for April 30, 2020, and before May 31st, 2020. And then we just look at the first few rows. So for TB1, that's just a pipeline. So what this means is take this table, we are going to apply this filter. What this filter means is the first condition is what? Dates is greater than that. The second one is what? Dates is less than that. And then after this operation, we use the header command, just look at the first few rows. So now, so this apparently, because this is greater than sign, is absolute great. So the April 30 is not included. We actually can change that into this year, I guess. 2021, maybe March 30. Well, the most recent one is actually May 16, so let's just do that. Oh, sorry, it cannot because you cannot have the later year less than that. So I forgot to change this into 21. Okay, so now, yeah, is this much smaller than last year? I don't remember last year. So it's a few thousand last year. This time is what? Actually, last year this time is also very small because it hadn't spread it to Alabama yet. So, but for some reason now, because I guess because of the vaccine, we think everything is normal now. So, yeah. But it looked like last year, this time, Alabama has just a few cases. Anyhow, but now we have more more than 50 of the US has received the vaccine now. So. Okay, so we can also specify a variable. So, oh, that seems to be a typo there. So let's say we know one of the things we know about this. Oh, there's someone looking for help. If you want to see the table, you go to the go to the update the environment, and then click on that variable. So there's someone asked a question saying, how do you look at the entire table? So go to the top right environment, click on that, click on the variable you want to see. So, oh, you mean the expand the structure? There's a triangle next to the variable. Click on that triangle, you're going to expand the structure of that variable. So there's the very small triangle next to it. So, there's also a table. Okay, if you want to see that, you can also click, or you can just double click. What I often do, just double click. It looks like single click also works. So, okay, so if this is just to assign a different time window. Apparently, duration, but in this case, you can specify duration. If I want to look at 30-day window, so I want to see whether there's a holiday peak. So a 30-day. Based on our own experience, there's the there's the holiday peak or winter peak around Christmas. So pick.
Dr. Hong, I have a question. I don't have well, it probably won't mess it up, but on mine, it doesn't have the slash between the 15th and 2020 right
That's
there.
A typo. Yeah, that's a typo. Just put a slash there.
Okay, just making sure.
Yeah, so I don't know when did I delete that backslash. Yeah. So that's a 30-day window between Christmas. Yeah, so this one I'm using great equal than, so it's included December 15th. So it's actually a lot. I mean, several thousand. Well, if you think about that, that's actually less than now. So, gee. Oh, wait. This is cumulative data. Sorry, I forgot to mention. This is also cumulative result. So this is not a daily case. I forgot to mention that. So maybe nowadays it's very, very little now. So we can also pick a time window and plot it out. So I again pick this time window, but this time I'm going to call it the TB_sub for a chunk of it. And then use ggplot to plot this one out. And I'm going to use the dates as the horizontal axis because we are looking at a time series. And the cumulative cases are the vertical one. So if there, so this is actually indeed cumulative. So it is increasing. And well, because of the reporting is done by people, and most people don't really work on weekend, so you can actually see the case doesn't increase continuously. In fact, if you look at the dates, usually Monday and Sunday had the lowest one. That's because people do not work on weekend and they take a day or two to report it. So Monday people started working, and then Tuesday, Wednesday you see the result. So that's basically is the data, but that doesn't mean the virus doesn't work on. The virus doesn't spread on the weekend. It just means humans don't collect the data on the weekend. So, okay. This actually leads to some very troubling trend. If you want to analyze the patterns, you will clearly see a weekly pattern there. That's if you want to do convert that time series, you will see a weekly pattern there. So okay. So this is the entire table. Usually we want to look at a specific county, right? So many of our participants now from the Tuskegee area. So I think in Tuskegee area, based on Wikipedia, that's called Macon, Alabama, USA. Okay. So we're going to pick that as pick Macon, Alabama, US as the county we are going to analyze for this exercise. So, okay, we pick Macon, Alabama, USA. And then we can, this is just to basically repeat, read the Johns Hopkins data and do a transpose, rename the column with a combined key, pick, convert the dates into the columns, and then we are going to pick a window of 340 days. And then we plotted all the results of the current county, which is Macon, Alabama. So let's run this plot. So even though we have been spending almost half an hour on this, it's actually just a few lines. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines of code. So there. So TB sub, if we click on the TB sub, there, that's Macon, Alabama. Apparently 340 days from today is June 11. That sounds right. So, and all the way to today, all the way to yesterday, May 16. So cumulatively, Macon, Alabama has 16,013 cases. Those actually, that means very little now. Only 2 cases in yesterday, 4 cases the day before. But if we so we actually can use a function called EIFS. This is actually, if you recall, that's actually a Unix command. We can use the DIFF to convert the cumulative cases into daily cases. So there, we're going to use differ, convert all the cumulative cases into daily cases. But that means the first, we're going to missing one, because if we only count the difference, if you have 10 number, the difference only 9, right? 2 number, you have 1 difference. So we actually need to put a 0 at the first one to make it to make sure the array will be exactly the same length. So after do the differ, we put the 1 back in. That's called a local daily cases. And then we put it back into the data frame. So now we have the local daily cases. but there's no date. We have to put the date back. Now we call the new daily cases TB underscore daily sub, and then we put the date back. The date is what? Year, month, and the date. Put that back. So now we have the daily cases and the date side by side. We can also convert a row name back into the dates. So this is basically convert the row name. The row name currently is just 1, 2, 3, 4, 5, 6. It's just the sequential numbers. We can actually convert the data back into the date. That actually is more meaningful when we are looking at the table. And so now if you click on the, how do we call this? TB daily sub. So, oops, TB daily sub, this one. So, there. So the row number is date and daily cases and the date on the side. You may think why we have 2 different dates, because you need an actual separate column if you want to plot it. So, you need a row name if you want to read it visually. So, sure. And we can also name, instead of calling the daily case, we can to put a county name back. So then, instead of daily cases, we can just say, this is Macon, Alabama daily cases. And then we can plot this one out. So in this case, I'm going to plot the daily underscore sub with what? The horizontal is the date, which is YMD. Is that the way we call it? We call it YMD, year, month, and the date. And then the Y tab, Y-axis is basically the daily cases. And then we are going to add the scatter plot, which is a point. And then we are going to also add a smoothing line. Okay. Yes. So this is too big to show on my screen. So, well, we can actually generate the HTML. So then we will see everything. So it takes a while to generate HTML report. Oh, also because I have a lot of further analysis after this. But if you can generate the HTML, that means everything runs. So, okay, so we have the HTML. So I'm going to open with the browser, which actually give a much better view of to handle the HTML report. Yeah. So, okay, so for the COVID-19, chapter 1, COVID-19 transmission analysis. So now we have what? Plotting a time window. Oh, we're actually now in chapter 2. A county, define a county, pick a county, convert that into daily case and plot. So it looks like I have a typo here. It should be a second subtitle. I picked a third one. So it's a minor one. So, so there we have the plot with the smoothing function. So this is excuse me, Macon County, Alabama. So wow, it's actually pretty good. Even the highest case is only around 50. But even there, it seems to be a reporting abnormality. So It's actually pretty good. I mean, consider that's the worst case scenario, just 50 cases a day reporting, right? So the worrisome is it actually does look like a picking up a little bit recently. So at Apple, the lowest, but somehow it's going up. Last night, it's a short-term window, so you don't know what will happen. With more people vaccinated, you don't know what that trend will go in the next few weeks. But it does look like there's a peak in January something over here. That's we started only in June, so 340 days. So, according to our schedule, we are going to do the Google mobility after the break. So that's actually neat. Google mobility. Apparently, GitHub now can handle files larger than 50 meg. So I put the apparently I can upload the Google mobility file directly into GitHub. So that's actually probably shouldn't be a problem. So you don't even need to download the GitHub, download the Google mobility. So even though in my code I say download, you do not need to. Do not need this because files are on GitHub. Because Google report. So even last year, GitHub still limit the file size at 50 meg, but apparently recently they lifted that threshold to 100 meg. So that's not an issue anymore. So and you can still download it. That will give you the most recent one. So I'm going to pause here and help people troubleshoot, and then we come back with the Google mobility one. Anyone need help?
I think someone has their hand. I can see someone has their hand up.
Oh yes,
in my window.
I see. Okay. Oh, so Innocent, can you share your screen or what's I guess what's the hello? Hey, Innocent.
I was able to, sorry, I was able to go through it. Let me remove it.
Oh, okay, okay. Yeah.
Thank you.
Okay, William Pleasant, can you share your screen? Can you share your screen so we can see what the issue you are having? Okay, okay, good. I see your screen. Okay.
So when I try to run literally anything, I get this error down here relating to XFun. And it wasn't happening before I tried to install the packages, and it like affects all of the code chunks. So I can't like run the library commands or the read Excel files, but I like have the packages.
Okay. I think you accidentally override some base function. Can you at the bottom when you type question mark, at the bottom type question mark? Good. Yes, question mark XFun. Yeah, it looks like you override some base function there. Well, this is really a weird thing in computer science. If things doesn't work quit everything, restarted.
Yeah, so I tried that. I even
Okay.
tried uninstalling and reinstalling both
No,
R.
no, 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 no. Quit RStudio, they come back.
Yeah, I've tried that before, but
Okay.
I tried to quit it and relaunch it,
Okay.
and then I tried to reinstall everything. Like I uninstalled R and R Studio, no luck. Same issue.
I think
Can
there
you
was
try the RStudio cloud version?
Um,
That will at least if it look like your somehow your R or R Studio setting or configuration somehow is messed up. It will be really strange if you uninstall or reinstall still have the problem. But for the time being, if you go to the R Studio Cloud and then just use that environment, you will save this. You're going to you shouldn't have this problem anymore. So. But this is really weird problem. Can you click Learn R through Johns Hopkins COVID-19? Can you click that tab? Yes, I run the first part. Nothing happened. Then run the next part. Okay, nothing happened. The code is not even running. This is basically you are not even running our Markdown. Nothing is even running here. So this is the if something is really wrong with the configuration here.
What type
Nothing
of
is running.
computer do you have?
Sorry, what?
Mac.
Is it basically RStudio is not even running R code. So
Yeah. I can't run any code at all.
I was told to unzip it because I had an issue trying to run it, and I was told to zip the files, I think. I can't remember. I can't really explain it, but I was told to click the zip file, and that's the one that I had to use. If not, then the other ones weren't going to open. I'm not sure if it's the same thing with Mac because I have Windows, but that's what I was told.
yeah, Mac you shouldn't have that problem. It's automatically in it. Besides, he's seeing the file directly.
William.
Okay. William, it goes down to your bottom command window. Just type say 1+2. Type 1+2. Okay, that part is still wrong. Somehow in your Markdown interpreter has a problem. But that's it's I never see this problem. I think you should just uninstall RStudio or try again, or use the cloud version of RStudio. This is really weird.
We've been running into a lot of these.
Really?
yeah the problem with the Mac.
Yeah, so I think it's you need to install Xcode, the command line tools.
Oh, is it the Xcode problem?
So yeah, so because I think a lot of the R packages on Mac relies on the command lines to install.
Okay.
Here, I'll paste that in.
I
So
see.
you just open up Terminal on your Mac and run that code I just sent, and then reinstall your libraries, and it should work.
Oh, good. I have a very good. So this actually is the Xcode problem, I guess.
Yeah,
Huh.
but you might need to like reinstall, and if they're all there, you might just type in install.package XFun just so it has that one, and if it's missing any others, but
Okay, very good, Trevor. I haven't realized this is the Xcode problem.
Just to make sure, you said like I ran it before. This line right here, right?
mm-hmm.
You
Okay.
need to be a root user to do that, I believe.
I think it's been working without. It should pop up another window.
Oh, okay.
Yeah, okay. I should be fine then. I'll wait for that before I.
And then if it's still coming up with that problem, just make sure you reinstall the libraries on R then, and then it should work better.
Got it.
Okay, very good. I need to write this down because this may be a common problem later on. So
I have a question. Are you able to look at my data to see if I did it correctly?
sure, can you share your screen, Moni?
Oh. I think I got the wrong region, sub-region. We were looking at Alabama, right?
You're looking at Wyoming? Oh, Alabama. Now I see what Alabama. So Macon, Alabama. Yeah. Scroll down.
Is this correct? Because it says it's in a negative. That's
Oh no, those are normalized. I think you already go to the afternoon session. Those are normalized daily cases for overlay. So before you overlay, you need to normalize things into the same scale. So we normalize everything into that to the standard one. So scale it. Yeah, that's okay. Yeah. So that's actually those are the afternoon sessions. You already go to the overlay or mobility with daily cases already. So, but it means everything runs. So, yeah. Okay, let's have a break, then come back, and then we add the Google mobility into this. Yeah, very good. Okay, I'll see you in about let's see on our schedule. What do we see? Our schedule is say meet at 2. Did we say meet at 2? 2:10. Yeah, in about 30 minutes. Okay, yeah.